Hey all, welcome back. In this video, we will be solving quiz 2 last term question paper. I will be explaining you the theory or the logic behind the solution. Then we will see the solution itself and I will at last share some tips. However, the video will be split in two parts. In the first part, we will be tackling the theory questions and the second part, we will be tackling the calculative or mathematical based question. A small disclaimer, all the solutions and the logics are my own. I don't know if they are right or wrong. So if you find any discrepancy in any of the solution logic or theory I used to solve the question, kindly let me know in the comments along with the question number itself. So with that, let's start today's session. So guys, just to make sure that we are on the same page, you can see that this particular question paper is of 4th August 2024, which was as well last term's quiz 2. Let's now move on to question paper and see what all we can do. So guys, here is our first question number 123 on your question paper, and it says that given the following code for polynomial regression. So here is the code and it asks you what are the coefficient of the model. So let's look at the code. Here we import the polynomial features from pre-processing and estimator called linear regression, then numpy as np. And here we have created our data for x, that is our training data, and we have reshaped it to 1 minus 1. So basically what this does is just creates a column of value. Okay? And this is our test data, by the way. And here we have set our polynomial features degree to interaction only is equal to false. So this will make sure that you will have your square terms or quadratic terms as per what is defined by this degree. So here it says degree is equal to 2, right? So it means that maximum it can reach is 2. So x1 y like power 1 and power 1. Okay, multiplication is there, or you can have x square or y square. And here we are fitting our model linear regression. Again we are applying and then we are creating x poly. So x poly is nothing but the polynomial features that we have defined here, as you can see. And here we are printing the model coefficients. So in case of linear regression, you have something as ax0 plus ax1 plus ax2 plus up to axn plus b. Okay, and since this is a polynomial feature transformation, so you will have different type of variables. So at max that you can have for any degree will be the equation like a0 plus a1x plus a1x square. So you need to focus on these a's, right? And here you need to compare these values. In these type of questions, mostly these type of values will have some kind of pattern. So by clearly seeing this, you can identify that this y is nothing but x square. But you know that these all values will have all these terms a0, a1, and so what can be the value so that this a terms get vanished and only this x square terms remain. And that is only possible when a0 is equal to 0, a1 is equal to 0, and a2 is 1. In that case, you will have 0 plus x square. So this equation can be formed, right? So that means the coefficient value can only be this particular thing, which is 0, 0, 1. And let's check if this is right or not. Yes, it is right. Okay, now let's move on to our next question. So it asks for what is the naive assumption in classifier based on naive Bayes. So naive Bayes basically works on Bayes theorem, and by statistics you know that in Bayes theorem we always assume that our classes or the outcome are independent. Now here these things will be replaced by features. Okay, so it will just predict different features based on its probability distribution. So all classes are conditionally independent of each other. Basically not classes, we need features, right? All classes are conditionally dependent? No. Even classes is wrong and dependent is wrong. All the features are conditionally dependent on each other? No, they are independent, else Bayes assumption fails by default, right? So that's why all the features are conditionally independent of each other. So that's the right answer here. Okay, I hope that you got this. Now in question number 125, it says consider the following snippet. Rich classifier normalize is equal to false and dash is equal to 0. So pipe is equal to make pipeline, min max scalar and estimator, pipe rich dot fit x comma y. So here they have just created a pipeline, nothing else. First they are scaling the values and then they are taking this estimator, which is our rich classifier. It says if we want to apply rich classifier with no regularization, what will the missing attribute? So here you can either go by MCQ method or just know this particular theory or fact that whenever you want no regularization, then you always set your alpha is equal to 0. And this is because this alpha controls the regularization rate. And what this all means is that here you are using ridge regularization, which means that whenever a value which is very large will tend to 0, but it will not be exactly 0, okay? So that our model can perform well. We will see why this is important in coming up questions, okay? And this is again a theory, so make sure that you refer to the documentation for verifiability, okay? So here you can see that CV basically means cross validation, which we don't want. Regularization rate. So regularization rate can be set, but even if you set regularization rate and you set alpha is equal to 0, that means that it will control the parameter of regularization rate. So this is wrong. Tolerance, how much tolerant you can be, so wrong. Lambda, not a possible value, none of these wrong. So alpha is the only value which is there. This is a trick question actually. Most times we see that regularization rate can be the answer, right? But this is not true. Here you have to set your alpha, and if you have done machine learning thoroughly, then you will understand this why. Now, what is the effect of increasing the regularization parameter alpha in ridge regression? So now let's understand what ridge regression actually does. Okay, so if we say a model which has 0.1 x1 plus 0.3 x2 plus 0.002 x3. So you can see that this 0.1, 0.3 and 0.002 are nothing but weights, right? And weights basically signify how important our model is. So when we say how important model weight is, it simply means that how important that particular feature is, because it's a multiplication here, right? So x1 is 0.1 important, x2 is most important because 0.3, right? So in that case, it becomes important. But what if our values tend to be like 1000 x1 plus 2000 x2 plus 3x3, right? In such case, values become very large and multiplication becomes hectic, right? So to handle those, we tend to make sure that these values are downscaled so that when training, they don't go till this much, and we set that particular value using our alpha. So what we do is we just multiply it 1 by n or some other value so that this value, when we multiply with this, becomes in 0.00 something, right? So these values get scaled here and we get our influence of the model. And when we set our regression rate parameter alpha in ridge regression, it simply means that we are setting the threshold value. Okay, so if we set our threshold value, it will decrease the complexity. Now this might seem counterintuitive to what we know, but the real fact is this, that when you have these values, you can see that it is overfitting the model, right? It is overfitting because it's very large values, right? So if we decrease it, model gets a good sense of what are the important values there, right? So in that case, the model generalizes well. You can think of it as a biased decision of buying something versus generally buying something, right? So in biased decision, you tend to favor two of different factors, and that's what our model does in the first case, which is here. And in general buying, you just look at the most efficient, convenient, and what is most the important one, right? So for that, that's the model too. So that's the main thing. So I just tried to explain you things. So increases the complexity of model, wrong, because complexity is increased by default. We need to reduce the complexity of the model by increasing the regularization rate. Okay, it reduces the complexity of model, yes, because our model now tends to generalize well due to our regularization. Okay, has no effect on the model, wrong. Increases the model sensitivity to the training data, wrong. Now moving on to our next question, which simply says, from the given code below, what do the coefficient represents, right? So here is the code. From sklearn.dataset import fetch California housing. From sklearn.linear model import linear regression. Data is equal to fetch California housing xy data.data and data.target. So these are our features, these are our labels. Okay, and model is linear regression, model fit, and model coefficient. So what are the coefficient represents? So I have already explained what coefficient represent in our previous question, but you have to go with the answers given in the options. So it represents the value of hyperparameter model. No, linear regression don't have a lot of hyperparameter unless only until you use stochastic gradient descent method. Intercept of the linear regression side, no, it's model.intercept underscore. Residuals of the model? No, that's SSR, but it is not given in the directly. And the last is importance of each feature in predicting the targets. As I explained, right? If we have 0.3 x1 plus 0.1 x2 plus 0.0003 x3, so most probably the most prominent feature will be x1, and then next most prominent will be x2. So it's kind of explaining you the importance of each feature in predicting your target. Now, question number 128, again a theory question. It says if we want to both ridge and lasso regression machine learning model, how can we use that? When you use ridge plus rago, you use elastic net. So you always get the benefit of both the world, and by default ridge makes your values go to 0, but it's not exactly 0. Okay, on the other hand, lasso will make your most of the features coefficients to 0, and only relevant will remain. Again, you can look at all the details on the online material. So here it says by setting the parameter to L2, that's always ridge. By setting the parameter to L1, that's always lasso. By setting parameter to elastic net, yes, this is the thing that we want. By setting the parameter to L3, L3 is nothing because either you have L1, L2 or elastic net in your quotations, right? It is not L3. L3 is just too tricky. Okay, now after that we have our next question. So our next question is question number 129, and it says which of the following type of classification problem is being solved when a model predicts multiple labels greater than 2 for each instance. So each instance basically means sample. Okay, and it says that you have multiple labels. Multiple labels, say you have for dog its breed, what it likes as food, and obviously each dog will have different specification, right? So here our label also changes. First we have this our class, and then we have our label. So in that case you have multiple classes plus multiple labels. So multi-class, multi-label classification. Okay, and it is not binary because it's not 0 1 binary class multi-label. No, wrong. Multi-class single label. It's not single label. So it's question number 130 now. Given the code snippet, assume if any necessary requirement from sklearn.model selection import grid search CV. So this for hyperparameter tuning. For sklearn.model selection import logistic regression again for model. So parameter grid is C. These values penalty L1, L2, and solver is linear. Okay. Grid search CV, logistic params grid CV is equal to 5. This, and then clf.fit x underscore train, y underscore train, print clf.best params. Okay, so don't worry about these, just focus on the question. What does CV is equal to 5 signify in the context? So cross validation, what it does, you need to remember that theory. Okay, or you can always check the options also. The training data is split into 5 different classes, each used to train separate models. No, that's not the case for logistic regression. It just trains only once. Okay, the model is trained and evaluated using 5-fold cross validation for hyperparameter tuning. That's right, because CV is cross validation, and we also have this hyperparameter tuning available with us. 5 different models are trained on 5 resample data set of training data. No, that's wrong, because nowhere it has been said that we need to resample the data using any of the parameter, right? Data is divided into 5 parts and trained in a single pass without cross validation. No. So here I will also explain you a little bit about cross validation. So you have your this entire data, right? And you want to check if your model is robust against different iterations. So what you can do is you can split your data defined as how many folds you want. So here the k will define that, say k is our 4. Now you will take one particular split as your test data and rest all as your training data. So you will train on these 3 folds and test it on the 4th one. Okay, and you will do this iteratively till all the things are exhausted. So in that case, if you get your model score as very close to each other, then it means you are doing a very good job at predicting them. So, okay, now this marks the end of this particular question. Now let's move on to our question number 131. So question number 131 says, consider the following code and assume all the imports being made from sklearn.linear model import perceptron. So xtrain, xtest, ytrain, ytest, mnist is the data set that we all know, perceptron, then clf.fit xtrain, ytrain. Okay, print clf.score xtest, ytest. Okay, now it says that what does score method compute in this context? So you can see that we haven't imported any specific type of score from our metric model, right? So that means that we will be using default. Perceptron is a linear model, and whenever we have a linear model in our scikit-learn card, most of the time this score will by default will give you an accuracy. So that means that we have our answer. The number of correctly classified samples wrong. Loss function value wrong. Number of misclassified samples wrong. The accuracy of the classifier. Always remember this particular thing. That will help you a lot. Now moving on to the next question. Question number 132. It says given the following code snippet, multi-label classification problem. What does multi-output classifier do in this context? Again a theory question. Okay. From sklearn.multi-output import multi-output classifier. From sklearn.linear model import logistic regression. Multi-output classifier logistic regression. So it is using logistic regression as an estimator for our multi-output classifier. And multi-output because it is a multi-label classification problem. We are fitting that model and predicting the model. Now what this multi-output classifier does, that you need to know. So it will not train a single logistic model. Okay. It will check how many targets classes you have, like say 0, 1, 2, 3. Okay. And for each of the class, it will train a logistic regression model. So you can see that train a single logistic regression model for labels wrong. Combine logistic regression with another model wrong because we have only used logistic regression. Apply logistic regression 1 versus rest strategy for multi-classification wrong. It will train a separate logistic regression model for each of the level as I showed you earlier, right? So this marks the end of this question. Now moving on to our question number 133. What is the main advantage of randomized search CV over grid search CV? So again a theory question. So main advantage of randomized search CV over grid search CV is that in grid search you have this grid, so it will check all combinations, very time consuming, right? Also if you want a lot of parameters, then this grid will also be very large, and if it is very large, that means finding the right hyperparameters become very inefficient. On the other hand, randomized search CV also use this grid method, but it just takes some random value and then based on the learning that it has learned, it will try to reduce the number of hyperparameters in the training space by eliminating them. Okay, and then it will find ones that gives us good result. And due to this approach, it is very easy to do HPT on very large hyperparameter space. Okay, so based on this, we will have our answer. Randomized search always faster, not always faster. Randomized search CV evaluates all possible combination of hyperparameter. No, that's grid search CV does, and I use a grid search CV as GSLV. Okay, and randomized search CV can sample a large hyperparameter space with fewer iteration. That's true. Randomized search CV always finds the best model. No, this is wrong because we have already removed most of the possible values which can be there, right? So this is wrong. Now moving on to question number 134. So this is again a theory question. If you know the parameters, you will do this right, else maybe wrong. So here it says when using SGD classifier with loss is equal to squared loss and penalty is equal to L2, which of the model given in the option are you training? So whenever we have loss as a squared loss and penalty as S2, remember I said that penalty L2 is ridge and we have this classifier, so that means we will be using ridge classifier. And if you see here, logistic regression wrong, perceptron wrong, ridge classifier, it's right. Okay, SBM also not there. 135. What type of classification problem is perceptron algorithm best suited for? So perceptron basically draws a linear boundary and it will always work if the data set is linearly separable. That means you can separate that particular data set using just a single line or a hyperplane. You don't have to go for a complex thing, right? So in that case it will work, and it works best for binary cases because ultimately it is used for classification most of the times. So what type of classification problem perceptron algorithm best suited for? It is for linear separable binary classification problem. So non-linear classification problem, regression problem, unsupervised learning problem. So unsupervised you can directly cut off because it is a supervised learning problem. Regression problem, no. Bunch of perceptron can, but a single perceptron can't. Okay. Non-linear classification problem, no. It's always a linear classification problem. So that's why. Now this is an interesting question one, guys, because this is a trick question again. What will the output of following code? Given output is iris.target name is cetacean, versicolor, and virginica. So look at your code and you can see that we have used a Gaussian naive Bayes and it is printing our classes, right? And we already know that the classes which is present in our Y has this iris.target and target is setosa, versicolor, virginica, right? As per Gaussian naive Bayes, you don't have to worry, right? All you need to do is just focus on the classes, and it is said that the target name by default is giving us this, right? Whatever you will be getting, you will be using that to feed your Gaussian naive Bayes model, right? So obviously the output should always be 0, 1, 2, basically labels which we have encoded, because because we all know that any machine learning model requires this particular numeric values. So let's check the options and try to eliminate this. So it is Setosa versicolor virginica. We can't get because we always want to predict on values and then we change it back to our class's name. Setosa versicolor wrong. None of these wrong. 01 wrong. 012 as I said earlier, right? So this is the thing. So by default class returns the index also. So from there also you can get this, but you can also do this particular hypothesis to solve it. Okay. Now question number 137. What is the default loss value in SGD classifier API and it gives which classifier? Okay. So again a theory question, and SGD default loss value is actually hinge loss. And whenever you have this hinge loss, that is this type of loss, it is always for SVM. Make sure that you remember this. So log loss, logistic loss wrong, log loss, logistic loss wrong. Hinge can never be for perceptron, so wrong. So hinge for SVM. Now moving on to our next question, question number 138, and it says you are working with the dataset containing 1000 samples, aiming to classify them using k nearest neighbors from scikit-learn. After trying an initial configuration, you observe that model seems to be overfitting with following accuracies: training accuracy 98, validation accuracy 65. After observing such performance, which of the following values of n neighbors would be most suitable to try next? So here you have to observe things. First thing is you have neighbors as only 4. 4 neighbors are going to define your decisions. So is that a good option? First of all, ask this. Obviously, if I have to buy a phone, I would not go and consult to 4 people only. I will consult to more than 4, maybe 6, 8, 10, 12, 15, right? But yes, again, I will not be going to consult 100 people or maybe 500 people because that will not be a feasible. So same thing we are doing in our key nearest neighbors also, right? So here if it is since 4, then chances are most probably it will get biased. Yeah, our training accuracy is 98% and validation accuracy is 65%. So that means there is a huge gap in this particular training and validation accuracy, which means our model has learned to predict on training data very well, but it's performing very poorly in our validation data or test data, whatever you can say, okay? Because obviously this validation data accuracy will get translated to test data also. As you can see that it is a case of overfitting, and to reduce overfitting for any KNN, the best way is to increase neighbors, because the more you have, the better you get. But obviously you don't have to increase it to extreme values. So 1, obviously less than that, no point in doing that. 2, very less than that, no point in doing it. 500, no point, as I said, no extreme values, right? So only option left is 10. Again, I will be skipping question number 139 for now. Question number 140 also. Question number 141 also. Question number 142 we can see, because it is again a theory question rather than a calculative based questions. Okay, so it asks for fill the missing parameter value in the following estimator that can be used to classify the data. Okay, so let's check what is the question. From sklearn import svc, means support vector classifier. CLF is equal to svc kernel is equal to dash. So kernel basically means something in non-linear terms. Okay, that means that your data set is not linear, so you can't directly draw a line to separate it. You have a very different decision boundary which is non-linear, maybe a circle or maybe an oval or something like that in simple terms. Okay, if I have a data like this, okay, and there are say 2 classes, so maybe this class and this class. So obviously this data can't be directly separated, right? So in that case you need to create some kind of decision boundary like this. You can see that your data is now perfectly separated. We can say that this is a non-linear case, and also in this type of data you can always transcend it to some higher dimension and try to find a hyperplane for this. So for doing this particular transformation you require this particular thing called kernel. Now there can be many kernels, so let's check if our data has some properties which can make it a linear kernel. So here our array 5 6 3 9 1 5 0 2 8 and 4 4 2. You can clearly see there is no sort of relationship with each other, so you can't use the linear kernel. So linear kernel fails. So next is polykernel. Fact about polykernel is that you don't need to understand the actual transformation that's going on. Just assume that there, at some higher dimension this can be translated, and most of the cases this can be. So polykernel can be a better fit. Let's see if polykernel is available to us or not. Yeah, polykernel is available, and again since it is a non-linear data, data as per our this. We also have this radial basis function, which is again a non-linear decision boundary. Now, for why not lasso? Because lasso is linear and we don't require linear here. So again, 142 is a very important and interesting question to solve. Now, question number 143. Which of the following scikit-learn module supports incremental learning through partial? So partial fit always works only when you have some iterative method. And here again, you need to know a little bit of theory and implementation detail. So you can always refer to your documentation. Okay. And in our scikit-learn, there are many iterative methods. One being the scikit-learn classifier itself. Now, one might argue linear regression is also there, but no, it is not a linear regression because we have two methods in scikit-learn to implement things. One is the functional method, where we just try to find the equation itself, and this is done by linear regression or logistic regression. And second is iterative method, and in this one, we use our base class and set the parameters in such a way that it represents that functional method. And this is called a lower level implementation detail, by the way. Perceptron, not SVC, because support vector classifier don't use any gradient method, right? It is not an iterative approach. It's just one approach and you need to find the best fit hyperplane with the best margin, okay, for the classification. And this linear regression already explained, right? So this marks the question number 143. And now one might argue, what is the partial fit? Partial fit is basically a way to load your data in batches and train up to till that point, and then when you load a new batch, you use this particular point to start again your training. This is only possible if you have an iterative method so that you can store things. So SGD classifier works well. So 143 done. Now question number 144, a very interesting question, and it will also be a very important one if you want to understand what SVM or SVC does. Okay, so following options are true for evaluation parameter C in sklearn svm.svc. So SVC means support vector class. We have many options, but you need to first understand what SVC does. Okay, so as I hinted earlier also, now I am going to explain everything here. Okay? So most of the time, what logistic regression does is it just creates a boundary. But what if our point lies very close to this, right? In that case, it might misidentify things. And to fix that issue, it is very important that we create a boundary. Let's say we have this boundary. So point on this area and point on this area are good to go. We don't need to worry about them because they will directly be classified, right? For most of the cases. And assuming that we have a good decision. But things might go wrong if our decision point lies in this region or maybe at this particular point, right? So if the point lies in this region also, right? So we are good to go. There are two cases. Either one can be that these points are correctly classified, one that it is wrongly classified. In such a case, then we move this particular decision point. If that is not the case, it is right, then we are good to go. But what about this? So how we will identify this? So for this, we use something called support vectors. And the work of support vector is just to help classify whether a predicted class is right or wrong, and this does it in a sense a majority. Again, I'm not going into the mathematical details of it. It is very much dense, but this is the basic idea of it. Now, what does this regularization does? Let me explain you that. So basically, regularization controls this margin. So you can directly assume from here that if we have a smaller margin, that means that we have a very less between points, right? That means most of the points will be classified. And in such a case, most of the points are misclassified because this margin acted as a boundary, and with the help of support vectors, it tried to find the right thing, right? But here it is not the case because we don't have support vectors which lie in this or this particular region a lot, right? Most of the points are here because the boundary is very less. So this will cause underfit. That means that you are not getting a good hyperplane at all. Okay. So that was for this. If we have a small regularization parameter and regularization parameter, you can directly exchange it with the margin. Okay. On the other hand, if your margin is very large, you can see that there are a lot of points here. In this case, it will do very good, but on unseen data which are here, it may classify wrong because it has learned that the point that fall within this particular boundary is the one which we need to predict as right or wrong rather than focusing on this also. Okay, so in that case, what will happen is that your model will overfit. And in that particular instance, if you have a large value of C, that is large margin, that is regulation parameter, it will overfit the training set with a complex decision boundary will form. So guys, with this, we have come to an end of this particular video. Couple of details. All the resource will be present in the description, namely the question paper, the documentation, and the solution itself. Okay. Make sure that you practice and refer to the documentation to verify the implementation that I have shown. If I have done something wrong, please let me know in the comments. And part 2 will be coming very soon. If you are liking this particular video, make sure to add a like to it and share it with others and subscribe to the channel, press the bell notification. So with this, I will meet you in another video. Till then, bye bye.